Hey everybody, welcome back to the second part of episode 1 of the Blueprints to C++ series. So the last thing that we did in the first part was creating the C++ class here and created a blueprint out of it, put it into the scene, and if we simulate play, we can see, okay, we have a cone, but it has no functionality yet. So let's change that by creating the variables first. So what we have here in the blueprint version is one boolean and the float type. So let's create it in the header file. So what we need is another U property. I made a mistake here. It should be visible anywhere. Usually for those components, they shouldn't be edited. But these will be edited anywhere, and in a couple of seconds you can see why this is important. Let's call it blueprint read write and category like cone actor, whatever. So what we have first is a bool, b is up. Then let's copy this. Then we had a float min height. Then we had a float max height. We had a float max. And I think the float currency. Let us check for a while. We have currency. The speed is missing. So, of course, float speed. So this is our declaration, and now let's configure some default values. You do this in the constructor. So we define, you can do it in the constructor, or you can actually say speed equals 50 here, and the max value equals 200. So you can do it either here or there, but usually it's more cleaner if you declare it here, but use the the constructor, and set the value here. So max is equals to 200 and speed is 50. So if we compile this now, this should be fairly quick usually. So it compiled. If we go into our cone and click on the top or the class defaults, you can see in the details everything that variables declared in the actor class, your object, all these inheriting classes. But here you can see cone actor. We declared in our H file a category, and so everything is showing up in here. If you can actually edit it, but what we can do now, and it's better to do it, not do edit anywhere, do it like visible anywhere for the min height, max height only, and the currency. Let's compile it again. And you can see that once it's compiled and updated in the file, that now these values are not editable anywhere. But like I said, the next topic of the next episode will be U properties, so I will cover all of this stuff, what is possible or not, in the next episode. So we can actually change the default values here, or if we go into the cone, this is this one, and we can actually, where is it? Here, down here. We can actually set the speed, let's say, to 60 for this instance here. So now we have our variables, but we still need to work with it. So the next step would be, if we compare it to the blueprints, is setting up the original values in the BeginPlay. So let's go into BeginPlay, and there what we had first is get the actor location, setting up the other values. So let's do this. So I have a vector location equals get actor location. So you will see down the road that many function names like these are similar or are the same as, like you can see here from the class, because usually they call the same functions or wrapper functions. Actually, every node that you see here is a kind of C++ function call. But there are sometimes things where you look at the name and it says get world location, but it's actually get component location, for example, because in blueprints you can define meta tags, how the node is, or in C++ you can define meta tags, how the function is named in blueprints when you call it. So, but this is like, I don't want to get into deep right now. Just something to mention. So if you're converting stuff like this, in your scene functions like get actor locations, usually it always has this target on. So if target is actor and you can see target self, this means this actual object. If you're having other references to classes like the game state or other stuff, then you can see target is game state, and you would go into game state and see which function to call. But we will cover all this in the coming episodes. So let's continue. So we get the actor location and set like the current C value to the location dot C. Then we set the min height equals the location dot C, the max height equals plus the max value. So you can see it's what we have in here, like these noodles and adding this and so on, is just a few lines of code here. And this is, I think, in my opinion, a lot better to read and easier to understand. But I'm a programmer. For others, this blueprints, visual scripting might be better to understand, or so, I don't know. So let's continue. So this is kind of like now what we did in the begin play. We are setting the variables and based on the actor location. So the tick function. Now down to the meat of things. So the first thing that we did, was calculating a variable here. And one thing to mention as well, like the green functions that you can see here are pure functions. Every time they are called, they don't usually have like execution pins and so on. Every time this one, like the plus here and the minus, this is calculated again for the plus and again for the minus. So speed times delta seconds is actually calculated 2 times in this blueprint. The same with the get actor location. If we call it several times, it would always call this function again. Or we would need to place this in a temporary variable or and stuff. And this is what we are doing in C++ in a second. So, but just to mention that these blueprint pure functions, they are always called. They're usually the blue ones or the ones with the execution pins. They keep kind of like a cached when they return the value like this one here. This is cached, and once you access it several times, then it's not the function is not called anymore, but it accesses the cached value. But in C++, let's say, okay, so we have a value, and it's if you're coming from Unity and C# and stuff, you will discover that, or you will see that many times you see const and const functions, and this is a bit different than you're probably used to in other programming languages. So I won't go that deep now, but here it means like I declare this variable, this local variable const, so that I can't change it anymore. So it's defined that location cannot be changed. If I would, let's say, try to change it to another value, then you can see it's an error because I declared it as const. It's kind of like something to prevent people from changing values or to make it clearer to read and all that stuff. So, and writer, sometimes if I don't, let's say, I just say float val is delta time dot speed, and you can see it all over here. It could say define as const, but based on how you use it, if you're not changing it, then writer also allows you to kind of like refactor it with its help to a const value. So let's see what happens. And now we are in this part where we are looking at if it's up or down. And based on that, we are setting either the current C value with a plus or a minus value. And if B is up, else like this. Just to mention, because one part of this episode is also naming conventions and a code structure. So every variable has to start or has to be defined as camel case, like starting with a uppercase character and then continuing based on each word, like starting with uppercases again, and like cone, mesh, C and M is uppercase or speed. The only difference is that Boolean values, they have to start with a lower b. And when we are finished with the example, I have some recap, some slides that you can have a look at where this is shown as well. And the code structure, so like curly braces always start in the beginning of the next line. And if you are having single line if statements like we will have here, you can see in a second, current C plus val, and here it's minus val. So usually sometimes when you're coming from C# or other languages, it's completely allowed to, let's say, just as an example, to do this. If B is up like this is perfectly fine, but the Unreal coding convention states for better reading, or it's their standards for years now, even single line need to have curly braces. And as you can see here, what I mentioned, there's these green squiggly lines. This is what writer says local variable may be const, and like Alt and Enter on this line, I can refactor it and add to const. So writer really gets you in the habit of using const in many situations. So and once you use it for a longer time, you get really used to creating const automatically without its help anymore. So we have this part now, and now we need to create a vector, or get the actor location, create a vector, and set the actor location. And just to show you again, here you have these nodes. And for example, like with the setting the values and true and false, in here in C++, it's just these couple of lines, so much better to read. I know if I I can't mention it enough, but it's just my personal thing. So if you like blueprints, then it might not be as tedious for you, but yeah. But this course is like converting blueprints to C++. So anyways, let's continue. So we need the actor location. F vector, that's the, just to show you for a sec, I will go into details in next episode with the variable types. Like what you have over here, you have boolean, byte, integer, floats, name, strings, and there's vector. And vector usually the same with text, string, name. These are structs and the rotator, and those start with F. So usually what you do is you have an F vector, F rotator, and so on that you then define in C++. So location equals get actor location, the same thing we did over here, but because it's a tick, we can't just declare a variable and use it down here because it changes every time. So and we want to reuse this. You can see in the blueprint version, we are making a vector because we need to change the C value and stuff. And this is, like I said, a blueprint pure. It returns a value. You would have to save it and would need to change the value there if you want to reuse it. Usually they make a vector. But in this case, let's say we have the location and everything. The only thing that changes is the C value. So let's just do this. Location.c equals the current C value, and then set the actor location with that F vector. And this is because we are changing it, we don't declare it as const. And now the only thing that is left is to check if it has reached the min or max height. So if current C is greater than the max height, then B is up is false, and else if current C is less than min height, then we say B is up is true. And that's it for the tick function. So let's compile. See if everything is correct. Let's switch over to the editor, save that one here, and let's hit play, and you can see it works. And because we have different speeds defined and they move differently, so we can still say the cone, okay, it maybe goes higher, 250, but has a speed of 80. And the blueprint version, let's say, has only 150 and has a speed of 60. Let's simulate this again, and you can see it works setting these values, and we have the cone working. So that's actually the first real example that I just wanted to get you into seeing how conversion works, creating a base class, and so on. So, and like I mentioned in the beginning or in the first part, that it's really important to have the core functionality in C++, and like variables and several functions like you can see here, and have different or level dependent stuff like you can see. Let's close this one here for a second. Level dependent stuff like the cone mesh, adding these assets. Usually there is a way you can get this in C++, so you can see that it's under the hint here that it's game starter content shapes blah blah blah. You can get a location, but you would need to hard code that location in C++, and that's not really the best way. It's you shouldn't really do this. So assets, changing materials, defining some other things that I will cover later. This is best defined in blueprints. So, but we are having our own C++ class. You can see there are no variables. You could add now a variable, but this would be a blueprint variable. So let's delete this. You can even go into, let's say, this one has an event graph as well. So you could technically, because we declared blueprint read write. So in blueprints, you can actually read and write these variables. Okay, you can see if I type get current C, you can see here from the cone actor, you have access to it. You can even set it and so on. So you can actually do blueprint scripting on top of your C++ class. But what I wanted to show you, one last thing before we go back to the slides and recap what we did so far, is that if we have our cone BP, and there's a possibility we have the same names, min, height, for the variables. If we now reparent blueprint, and it's allowed to, let's say, reparent this blueprint to another parent class, and in our case it would be cone actor. Then what you can see is, we have all these errors because when you reparent it to a C++ class and you have variables declared in blueprints, Unreal changed its names to _0, and you get all these errors because it's a conflict between variables declared in C++ and variables declared in blueprints. So, and the same goes with some functions and so on. So you would really need to go in, if you compile, you can see error, you would need to go in for every time I use these variables, and replace them with the versions from, say, like this, get speed. So you would use the speed value, delete it, and this is why I said, or it's one thing why I said it's important that you have a base class in C++ defining all your variables there, and then start with you can add blueprints, test things out, but at least you have a base where you can access all these variables like here without having problems later on down the road. So that's this. So let's recap. We started by creating a base class in C++, or we started actually by creating the whole blueprint version. But based on that, we created the base class in C++, added the variables, added the component, implemented begin, play, and tick, and created a blueprint there from the C++ class, added it to the scene, and it kind of like worked. So, and this was really to show you how important it is, like I mentioned several times now, to have a C++ base. But why also blueprints are really important to use, like for these level dependent stuff and other things. So just take this with you from this episode. It's not blueprint C++ or blueprints only. It's a good combination of both. That's also what Epic says is the Epic way. As a short recap for the naming conventions, if you're seeing classes that, like, there are different types, it's only a few here, but UObject is your base class in the game framework, but you can't place this in the scene. Actor is the first class that you can then put it into the scene, and actor inherits from UObject. So classes usually, and that's what you can see here. Let me go to the editor. You can see that they have this prefix like a cone actor, a actor, U scene component, F vector. So these are the naming conventions that that Unreal has. So for actors, they start with an A, structs start with an F, enums with an E, and even other classes start with an F and so on. So just keep this in mind. The same, again, what I've shown you in code, camel case naming of variables, booleans start with a lowercase b, and use single line if statements with curly braces, and the curly braces always start on the next line. So for this episode, there's these naming conventions. There are a lot more, which I will cover the next videos. And the tip of the day, you might be wondering, hey, what's that? uint8 for Boolean. And you can see it a lot in what the Epic developers use, or how it's also used in the game framework. For better memory layout, it's preferable to, you have a lot of booleans. Instead of using bool, it's preferred to use uint8s that are defined like this. We can change this in a second now in our code, and initialize the value in the constructor. And if we have several booleans and place them underneath each other, then memory can be better layout for this class. So what you would do is, let's say for instead bool is up, we define a uint8, and this :1 defines that it's 1 byte. We still use the naming conventions for booleans, but instead of typing bool, you would go uint8. And if we are having several booleans, let's say like we also have a boolean b is initialized, we could do it like this. And in the cone actor, we would then say boolean is up is true, and b is initialized equals to false. And you can still use the true, false, and stuff. It's just another because the bool is, I think, 4 bytes or whatever, and here you just use 1 byte for true and false. And then, for example, we could go in, once we begin play, we set everything up, we could say b is initialized is true. So that's the tip of the day. And if you're wondering, just another tip maybe, if you're wondering, okay, how Unreal does it, let's say we take actor, you can go like hit F12, go into the actor in the code itself and look how they did it. And you can see here that actor implements or inherits from UObject, and this is how they, for example, also, like I mentioned, they use their booleans as uint8s. So just give it a try, play a little bit with it. And so thank you for watching. I hope you really enjoyed this episode here. And like I said, also, if you want to get notified when new episodes are coming out, then you can subscribe to the channel. And I would appreciate likes for that video. And then see you in the next video. Episode 2, Your Properties, coming up soon. Bye bye.